Assalamualaikum and greeting to all who watch my video. My name is Muhammad Azman bin Mahir with metric number DN180080. My main supervisor is Technologist Dr. Nurhanis Hayati binti Hayrom from JTKK FTK, and my co-supervisor is Technologist Zarizi bin Awang from JTKA FTK. In this video, I will presenting my final year project 1 with title Palm Oil Mill Secondary Effluent Treatment via Membrane Photocatalytic Reactor under different concentration and membranes. In this presentation, I will include an introduction, literature review, methodology, and expected result of my proposed project.
Introduction.
You know that Malaysia is one of the world's largest producer and exporter of crude palm oil. Together with Indonesia, they are the major producer and accounting for almost 80% of worldwide output. Admittedly, during the extraction phase of palm oil, a massive amount of palm oil mill effluent, also known as POMSE, is accumulated, resulting in extremely polluted agricultural wastewater. POMSE is considered as strong environmentally harmful, acidic, and organic-rich wastewater. Palm oil mill secondary effluent, also known as POMSE, is produced by the secondary biological treatment of POMSE. Despite the several treatments, the characteristics of POMSE do not correspond to the standard discharge of Environmental Quality Act 1974 by Department of Environment Malaysia. So, this research aimed to treat POMSE in the presence of zinc oxide nanoparticle as photocatalyst via membrane photocatalytic reactor. MPR stands for Membrane Photocatalytic Reactor, is a hybrid system that combines photocatalysis and membrane filtration process that gain a lot of attention for wastewater treatment due to the potential of MPR over current technologies. The MPR system it incorporates zinc oxide nanoparticle embedded onto clay as the photocatalyst is a new effluent treatment technique that is to be developed. This study is expected to have a major impact, especially on the palm oil sector, due to the potential to conserve the environment and ecosystem. So, for the problem statement here, as I mentioned earlier, POMSE was perceived to be highly polluting from wastewater to the environment and ecosystem. Despite the fact that the POMSE has been subjected to a number of treatments, the characteristics still do not fulfill the discharge requirement by Department of Environment Malaysia due to the pH, color, biochemical oxygen demand (BOD), chemical oxygen demand (COD), and turbidity level that are still elevated and deemed hazardous to release. The existing POMSE treatment also still fail and struggle to meet the allowed requirement to discharge into the water bodies. It is necessary to treat POMSE in order to compliance with the environmental protection standard for the water bodies. As the objective, there are three objectives of this project. First, to synthesize zinc oxide via precipitation method. Second, to evaluate the effect of the membrane and the initial concentration in MPR for POMSE treatment, and the last is to elucidate the mechanism of membrane fouling using model fitting according to the theory of the blocking filtration law. The scope of study for this purpose project firstly is synthesis of zinc oxide via precipitation method, then evaluation of the effect of different membrane which are ultrafiltration and nanofiltration, and the initial POMSE concentration which are 80%, 19%, and 100% in MPR for POMSE treatment. Next will be analysis of the permeate quality in terms of pH, color, biochemical oxygen demand, chemical oxygen demand, and turbidity. Lastly will be elucidation of the mechanism of membrane fouling using model fitting in the MATLAB according to the theory of blocking filtration law.
Literature review.
The conventional treatment of POMSE consists of anaerobic followed by aerobic bonding system. Because the anaerobic treated effluent still produce the dark brown color, improving the conventional bonding system is needed. Bonding system is a secondary treatment for palm oil effluent. The diagram shows the overall process in POMSE treatment, and the raw POMSE sample are collected from the polishing pond. POMSE has a propensity for being a high-strength industrial wastewater that is difficult to treat because of its wide range of inorganic and organic content. POMSE that has undergone a number of treatment still do not match the standard discharge by Department of Environment. Table below shows the standard limit provided by Department of Environment Malaysia. Considering the conventional treatment process failed, various methods have been explored to offer a better potential treatment. First, according to the Chang et al., when dealing with a land bank problem, anaerobic digestion tanks are used instead of bonding treatment, although at a higher expense. And second, the adsorption process also have a several benefits due to easy to use and comprehensive pre-treatment. However, the activated carbon employed in the process is costly material with a time-consuming operation. According to many ultrasonic also provided a potential treatment that use a low-frequency ultrasound to degrade organic matter, but it consumes a lot of energy and cause the chemical oxygen demand to fluctuate and inactive for higher total suspended treatment. Steam reforming is also a well treatment, but as a several drawbacks, such as being energy intensive, catalytic deactivation, and produce negative net H2. From all the recent treatment, a hybrid system of membrane photocatalytic reactor offer a more promising treatment for POMSE. According to the Siddiq et al., the presence of zinc OZC nanoparticle in the membrane photocatalytic reactor system for treating POMSE resulting a better color rejection performance up to 99% and provided a superior performance and efficiency to practically used in industrial wastewater treatment. Membrane photocatalytic reactor MPR has inspired a lot of interest in wastewater treatment in recent years. Many studies have been attracted to the potential of MPR over current technologies with a high ability for industrial purpose. MPR is a hybrid system that combines photocatalysis with membrane separation, with one technique complementing the other and overcoming the limitation of the other. MPR system has the potential to increase wastewater treatment performance and minimize flux decrease. The MPR system uses a continuous process to separate the catalyst and the pollen in wastewater and at the same time reduce the photocatalyst loss and also improve the reaction retention time. MPR is an advanced technology over the current treatment due to the main advantages such as keeping the photocatalyst confined in the reaction environment, realizing a continuous process with a simultaneously separate of catalyst and product, and also controlling the molecules retention time in a reactor make a big potential impact for POMSE treatment. Photocatalytic degradation process is the acceleration of a photoreaction in the presence of catalyst. According to Zarifa et al., the photocatalytic degradation process is one of the best options for degrading the POMSE, and according to Rafiq et al., photocatalysis is very efficient, renewable, stable, and environmentally acceptable process in pollutant removal. Heterogeneous photocatalysis of metal oxide such as zinc oxide demonstrates its efficiency in degrading a wide variety of different contamination into biodegradable molecules and harmful carbon dioxide and water. Zinc oxide nanoparticles have a properties with a band gap of 3.37 electron volt, strong photocatalytic activity, inexpensive cost, lack of toxicity, excellent chemical stability, and the best photocatalysis for degrading the contamination. Figure below shows the mechanism of photocatalytic degradation by zinc or catalyst. The photoexcitation of zinc OCC nanoparticle result in the generation of photo-induced electron hole pair. The generated of hydroxyl radical attack the organic pollutant in the POMSE and decompose it into simple molecules such as methane, carbon dioxide, water, and so on. Besides, the clay that chosen in this study is kaolin, which is an odorless mineral that comes in grayish to yellowish powder form. In this study, zinc oxide nanoparticle will embedded on clay through precipitation method in order to achieve the POMSE treatment. According to Mustafa et al., immobilized and attaching zinc oxide nanoparticle on clay mineral surface provided more active surface sites, minimize nanoparticle aggregation, and limit nanoparticle leaking into the environment. Membrane separation. Membrane separation is a method that selectively separates material via porous or small space in a continuous structure, molecular arrangement. Membrane separation are classified according to pore size and separation driving power. By exerting a driving force such as pressure across the membrane, chosen compound can be transferred across the membrane. Membrane separation offers a wide range of applications because to their many benefits including cost effectiveness, easy to operate, and high pre-concentration factor with high degree of selectivity. Furthermore, by selecting the type of membrane, significantly improve membrane filtering performance. There are two types of membrane chosen in this study, which are ultrafiltration and nanofiltration. Ultrafiltration membrane is a low-pressure membrane procedure that is utilized in a broad range of applications in industry. Ultrafiltration membranes spread range between nanofiltration and microfiltration, with pore size ranging from 0.001 to 0.05 micrometer, while nanofiltration membranes are relatively new technology that provide better ion selectivity and allow for greater flexibility in our suppression process development, which may have a significant influence on our performance, particularly in industrial applications such as removal of natural organic matter in wastewater treatment. Nanofiltration membrane suppression process ranging below 2 nanometer with a driving force 5 until 15 bar. Nanofiltration membranes are effectively for separating inorganic ion and tiny organic compounds.
Methodology.
The flow for this study will be start by synthesis zinc or clay nanoparticle. Then POMSE treatment will be conducted in MPR system in the presence of different membranes and initial POMSE concentration. After that, the quality of permeate will be checked whether it complies to standard or not. Lastly, analysis of membrane fouling mechanism will be conducted by using MATLAB software. The material and chemical will be used in this study are shown in the slide presentation. POMSE sample will be collected from the local palm oil mill in Kluang, Johor. Method for synthesis of zinc or clay nanoparticles. Firstly, 0.15 molar oxalic acid solution and 0.1 molar zinc acetate solution will be prepared and mixed together. After 5 minutes sterile, 10 grams of kaolin powder will be added and stirred for 12 hours. The reaction will give a precipitate product and it will be filtered and rinsed with a distillation water for several times. Next, precipitate will be dried in oven to remove water content and calcined in furnace to remove the impurities. For POMSE treatment via MPR, 2-liter photocatalytic reactor is a main component of the MPR used in this study. The performance of zinc or clay in MPR for POMSE degradation will be determined under different membranes which are ultrafiltration and nanofiltration. The operation temperature will be maintained steady under room temperature, which is 25 degrees C, by circulate the cooling water with a chiller. For photocatalyst activation, a UV lamp will be placed inside the reactor. The impeller is applied for complete stirring. The degraded effluent will be filtered through a flat sheet membrane unit at a transmembrane pressure under 6 bar using a masterflex peristaltic pump. The effluent will be collected in a measuring cylinder after it passes through the MPR. For permeate analysis, POMSE sample and zinc or clay nanoparticle will be stirred in the MPR to attain the adsorption-desorption equilibrium of photocatalyst and permeate will be pumped out. The permeate then will be tested using analytical method to check its pH, color, BOD, COD, and turbidity. Mechanism of membrane fouling will be elucidated using MATLAB software according to the laws modified by Wisner and Oill.
Expected result.
The expected result in the experiment have been clarified as follows to the objective study. The precipitation process is expected to be effective in the synthesis of zinc or clay nanoparticles. The performance of ultrafiltration membrane in the MPR is expected to be better than nanofiltration membrane in terms of normalized flux decline, intensity of color removal, and reduction of BOD, COD, and turbidity due to the effective filtration mechanism. After that, the quality of permeate in terms of color, BOD, COD, and turbidity is expected to comply with the standard quality of Environmental Quality Act 1974. And lastly, the flux decline and mechanism of membrane fouling is expected to be successfully elucidated through the model fitting based on the theory of blocking filtration laws, Wisner and Oill equation.
Conclusion.
In conclusion, the main objective of this study is to treat palm oil mill secondary effluent via membrane photocatalytic reactor under different membrane and initial POMSE concentration. It is projected that the ultrafiltration membrane will be the best final normalic flux among all the membrane, and as the concentration of POMSE decreases, the degradation is higher and less membrane fouling. Besides, the quality of treated POMSE is anticipated can be enhanced as followed to the national standard requirement. The reduction of POMSE characteristics such as pH, color, BOD, COD, and turbidity will be noticeable and follow to the standard requirement by Department of Environment Malaysia. Since the study of zinc oxide nanoparticle as a photocatalyst for wastewater treatment is comparatively low and minimal, this proposed extensive research and exploration is highly required to provide more knowledge and understanding.
Gantt charts.
Here is the Gantt chart of this proposed project. Gray indicates the planning progress and blue indicates the actual progress. That's all from me. Thank you.